Hello. In today's lesson, students, we are going to learn about the empirical and molecular formula. As you will be knowing, empirical formula is the whole number ratio of different elements present in a compound. Let's say, for example, we take a simple example, glucose. The molecular formula of glucose is C6H12O6. And if you simplify this one, so you can divide it by 6. So it's going to be, the simplest ratio between them is 1 carbon, 2 hydrogen and 1 oxygen. So the empirical formula of glucose is going to be CH2O, right? Similarly, butane, the molecular formula for butane is C4H10. So hence if we simplify it further into the empirical formula, so the empirical formula of butane is going to be C2H5. So in today's lesson, what we are going to study? We are going to study first empirical and molecular formula calculation from the percentage abundance of the element present in a compound. It's a very common question in both IGCSE and even in A Levels. So let's go to the first question. In this question, you can see over there, they have told us a compound, its percentage abundance is given for element, like a compound is having 3 elements, carbon, hydrogen and oxygen. The percentage of each element of the 3 elements is given, and you have been given even the molar mass or the molecular mass. Okay, so by using this data, we have to find first the empirical formula, and after calculating the empirical formula, we have to work out the molecular formula. So students, first of all, we have been given percentage in for all 3 elements. So what we can do, first of all, we have to find the moles. Okay, so similarly, like if they give you percentage, you can directly take it in grams. Let's say we are having 100 grams of a compound, so out of those 100 grams, 40% mean 40 grams are made up of carbon, 6.7 grams are hydrogen and 53.3 grams are oxygen. So what you can do, just divide the percentage by the molar mass. So you can divide 40 divided by 12, 6.7 divided by 1 and 53.3 divided by 16. That molar mass you can see from the periodic table. Okay, so when you divide it, so 40 divided you can divide 40 divided by 12, which give you 3.33. So you got the moles. Okay, so 3.33, and then for the other one, 6.7 over 1, it will get you same 6.70 you can say, and last one 53.3 divided by 16, the molar mass, so it's coming 3.33. Okay, so the first thing is you have to divide the mass divided by the molar mass, you get the moles. Okay, secondly, what you have to find the simplest whole number ratio. So what you can do, divide all of the moles by the smallest number, so to get the ratio. So you divide all of them by 3.33 because this is the smallest number, because among these 3 numbers this is the smallest number. So you can see here we'll get 1, and here we'll get 2, and here we'll get 1. Okay, so what you have to do, first of all, there are 2 steps. First, find the moles. After you get the moles, what you have to do, just get the simplest whole number ratio, and that number you just write under the element. So that is going to be called as empirical formula. So the empirical formula of the compound given is C1H2 and O1. Okay, so this is the empirical formula of the organic compound. Okay, so we can say the ratio, you will get the whole number ratio, the simplest whole number ratio, and this ratio is called the empirical formula. Now by using this empirical formula, now we have to work out the molecular formula. Okay, so in order to work out the molecular formula, the additional information is required. In the question, when you can see in the question, they will tell you the molar mass. Okay, so the molar mass of the unknown compound is 180 gram per mole. So this is the molar mass of the compound, and this will be given in the question. Okay, so in order to calculate the molecular formula from the empirical formula, we need to have the molar mass. Okay, so you can see glucose, the molar mass is given for you 180 grams per mole, and empirical formula you have just found, it was CH2O. So when you add them, it becomes there is one carbon, there are two hydrogen, and there is one oxygen. So when you add them up, it becomes total mass of this empirical formula becomes 30 grams. Okay, so molar mass is already given, and you have calculated the empirical formula mass. So what you have to do, you have to divide the molar mass by the empirical formula mass. Okay, so when you divide it, you get a number, let's say 6. Okay, so 180 over 30, you got 6. After you get this number, you just multiply this number, the number you got, multiply the empirical formula by this number. Okay, so when you multiply the empirical formula by 6, the molecular formula is going to be C6H12 and O6. Okay, so what is the empirical formula, molecular formula for this compound glucose is going to be C6H12 O6. Okay, so by this way you can calculate the molecular formula from the empirical formula. Okay, now let's go for the next example. Okay, in the next example you can see, I hope this is very clear. So if there is any doubt, we can go over the next example which make it further clear for you. Okay, so there is a unknown compound which is having 43.7% phosphorus and 56.3% oxygen, and the molar mass is again given for you, it's 284 grams per mole. By using this information, we have to work out the empirical and the molecular formula. Okay, again you will do in the same way. So you have been given the percentage, so first of all you have to find the moles. Okay, to find the moles, what you have to do, just divide the percentage given by the molar mass. Molar mass of phosphorus is 31. Okay, so you will divide that, and for oxygen 56.3 divided by 16. So 43.7 when you divide by 31, you are getting 1.41 to be precise. Okay, you get 1.41 here, and for this one 56.3 divided by 16, the molar mass of oxygen, so it comes to be 3.52. Okay, so again we have there are two elements, so you have to find the mole and then get the simplest ratio. Okay, so when you get the simplest ratio among them, you can see both of them you have to divide by 1. The smaller number is 1.41, so both of them you have to divide by 1.41 to get the ratio. Okay, 1.41. so here you will get 1 definitely. Over here we can check, so 3.52 divided by 1.41, so it's coming to be 2.5. Okay, students, here I have taken this example to make to clarify another doubt. Some students are doing this mistake. You know, in maths what we do, if we get a number like 2.5, we usually make it 3. But in empirical and molecular formula calculation, what you have to do, for example, you are getting a decimal number. Okay, so in this case don't round it off to 3. Okay, so what you have to do, keep it 2.5 only. To make it a whole number ratio, what you will do, multiply both of the numbers by 2. When you do it so what will happen, for phosphorus it will become 2, and for oxygen 2.5 into 2 will get you 5, because I told you already the empirical formula is the whole number ratio. Okay, so sometimes you are getting for example ratio of the mole in decimal points, so what you have to do, multiply either by 2, sometimes we have to multiply by 3 to make it a whole number ratio. Okay, so now you got the empirical formula. So the empirical formula of this compound is going to be P2O5. So I can write for you here. So the empirical formula of this compound of phosphorus is going to be P2O5. Please take care, whenever you get ratio in fractions or decimal point, what do, you have to make the whole number ratio, so that the whole number ratio is 2 and 5. So the empirical formula of this compound is going to be P2O5. I hope it is very clear. So now you have the empirical formula, and we are having the molar mass, as you know already, like we did for the first example also. So what you will do now, by using this empirical formula, now we are going to do the molecular formula. Okay, so like we did before also. So in order to find the molecular formula, first of all we have to find the empirical formula mass. Okay, you can see just now we calculated the empirical formula was P2O5. So it's having 2 phosphorus and 5 oxygen. When we add them, the total empirical formula mass is coming to be 142 grams. Okay, so now what you have to do, again we did in the first example also same way. So you have to divide, the molar mass is 284, so you have to divide 284 by 142. Okay, So you have to divide 284 divide by 142. I told you already the molar mass is given and empirical formula mass you have just calculated over here, so just divide them. So when you divide it by the molar mass by empirical formula mass, now you can see we will get 2. So whatever number you get, that number you have to multiply with the empirical formula. Okay, so this number you have to multiply with that, okay, to get the molecular formula. So when you multiply this number, see, so you got 2, so 2 into P2O5. So when you multiply this, you get the molecular formula. So the molecular formula of this compound is going to be P4O10. Okay, so whenever you are finding empirical and molecular formula, so just to review, let me tell you once again, because sometimes you know when you, the ratios are not a whole number ratio, so what you have to do, just multiply by 2, or sometimes we have to multiply by 3 or 4, whatever, so make it a whole number ratio. Okay, so when you get the whole number ratio, that is called the empirical formula. After you get the empirical formula, you have to find the empirical formula mass. And after you get the empirical formula mass, what you can do, the molar mass divided by empirical formula mass, and whatever number we are getting, just multiply that number with the empirical formula, so it will get you the molecular formula. Okay, I hope it's very clear. So today last topic, sometime in higher classes, like say, let's say for A levels, sometimes they ask us to find the empirical and molecular formula by combustion analysis. Okay, so now let's go for the last example. Okay, please have a look at this one. This is about molecular and empirical formula from combustion analysis. Okay, as you will be knowing, whenever we are having an organic compound, so whenever we have an organic compound which is having, let's say, I will take one example for you. Let's say I am having glucose. Okay, so glucose is C6H12O6. Okay, so when you burn this compound in air or in excess of oxygen, like we are taking excess of oxygen, so what are you going to get? You are going to get carbon dioxide and you will get water, right? So whenever an organic compound which contain carbon, hydrogen and oxygen, when you burn in excess of oxygen, you are going to get carbon dioxide and water. Okay, so we can balance it. Let's say we get 6 CO2 and we'll get 6 H2O, and to balance it we have to put just 6 over here, right? Okay, so when you actually, this calculation is based upon this fact, whenever organic compound you are burning, mostly it gives us carbon dioxide and it gives us water. Like these are the two common products which are formed by the complete combustion of an organic compound. Okay, so you can see there is a compound, there is a hydrocarbon which produces 25 like when you burn it, you are getting 25.15 grams of carbon dioxide and 11.58 grams of water, right? And they have given you again the molar mass is given for you, right? So by using this information, we have to work out the empirical and the molecular formula of the hydrocarbon. Okay, you know, in the lab they are doing this experiment this way. You have to analyze the compound you want to analyze. So you have to keep this compound over here in this test tube, and what do you do? Just pass oxygen over it and burn it. When you burn it, you can see the compound will make water, so that water will be absorbed over here, right? So the mass of water you can calculate by observing the change in the mass of this water absorber. And there is another liquid, usually we use potassium hydroxide. Okay, so potassium hydroxide, what it can absorb? It can absorb carbon dioxide. Okay, so the absorption of carbon dioxide will take place over here, and excess or unused oxygen will leave from here, right? Okay, so basically for this calculation, what we have to we have to use of one fact, that for example, if I can explain you this way. Carbon dioxide, the total mass of carbon dioxide is 1 carbon and there are 2 oxygen, right? So 16 into 2, so the total mass of carbon dioxide is 44 grams, right? So out of those 44 grams, this calculation is based upon this fact. So if I'm having 44 grams of carbon dioxide, out of those 44 grams, you can understand 12 grams is carbon. Okay, so it means out of 44 grams CO2, how many grams we have carbon? If I am having 44 grams of carbon dioxide, it will give me 12 grams of carbon, right? So like if I am having the mass of carbon dioxide produced, so I can work out the mass of carbon, right? Okay, please see. So from the mass of carbon dioxide, we can work out the mass of carbon, right? So as I said, 44 grams per mole is the molar mass of carbon dioxide. It contains 12 grams of carbon, right? So what we can do, we can apply this formula to work out the mass of carbon. Okay, so in order to find the mass of carbon, what is the formula? Molar mass of carbon divided by molar mass of CO2 multiplied by the mass of carbon dioxide produced. You can see when this compound was burned, it produced 25.15 grams of CO2, right? So what you will do, so to work out the mass of carbon, we can divide 12 over 44 into 25.15. It gives you 6.859 grams of carbon. Okay. And similarly, if I'm having water, see, you can understand in the same way. So you can see the total mass of water is, there are 2 hydrogen and there is 1 oxygen. So total mass of water is 18 grams. Okay, 2 plus 6, 18. And out of those 18 grams of H2O, how many grams of hydrogen are there? It is having 2 grams of hydrogen, right? Because there is 2 hydrogen atom present in water, right? So 18 grams of water is having 2 grams of hydrogen. Okay, so it means I can work out the mass of hydrogen from the mass of the water, right? So the formula to find the mass of hydrogen will be like that: mass of hydrogen divided by the mass of molar mass of water multiplied by the mass of water produced in the experiment. Okay, and you can see when this experiment was carried out, how many grams of water were produced? 11.58 grams of water, right? So what you will do, see, use this formula. So what you can do, the mass of hydrogen divided by the molar mass of water multiplied by mass of water produced in the experiment. So when you apply this formula, you are getting grams of hydrogen. Okay, now once you have, because you know it's a hydrocarbon means a compound which contains carbon and hydrogen only, right? So when you know the mass of carbon and the mass of hydrogen, remaining calculation are same. Okay, so what do you have to do? You know the mass of carbon and now you know the mass of hydrogen as well. Okay, so firstly what you have to do, you have to find the moles. Okay, so how will you find the mole? Like we did before also. So 6.859 over 12, the molar mass of carbon is 12, and 1.287 divided by 1. You can do 1, or to be precise, you can do 1.008. Okay, this is the exact molar mass of hydrogen. Okay, so now what you can do, 6.859 divided by 12. So it give you the moles. So the moles of carbon are 0.572. Okay, and the mole of hydrogen, now we can do 1.287 divided by 1.008. So it give you 1.27277. Okay, so better to take minimum 3 or 4 SF. Okay, because the numbers are very small. So after you get the moles, what is the next step? You have to get the ratio. So to get the ratio between the mole, the smaller number is this one. Okay, so you get moles of carbon. Moles of carbon are 0.571, and mole of hydrogen, you can see over here, is 1.287, right? And after that, what do? You get the ratio between them. When you get the ratio, now for carbon it's coming 1, because obviously the smaller number is 0.57, right? So you have to divide by 0.571. Even this one you have to divide by 0.571, and again you are getting a decimal number like 2.25. Okay, as I told you before, sometime in the previous example we were multiplying by 2 to make a whole number. This time you have to multiply both of these ratio to get the whole number ratio. We have to multiply by 4. Okay, so when you multiply by 4, you can see for hydrogen it will become a whole number of 9. 2.25 into 4 will get you 9, and for carbon it's coming 1 into 4 is coming 4. So it means the empirical formula of this compound is going to be C4H9. Okay, so this is called the empirical formula. Okay, so the compound which was given for us, so we got the carbon and hydrogen ratios, and again ratios were not a whole number ratio, so we have to make it a whole number ratio, and after we get the whole number ratio, it's going to be C4H9. Okay, this is the empirical formula. Now you can see the molecular formula was given, the molecular formula mass was given for you already. It was 114 grams per mole. Okay, so last step, what you will do now, you have to find that number. Okay, like we did before also. So the empirical formula mass you can work out. Okay, so empirical formula mass you have to work out. So it's having 4 carbons, so 12 into 4 plus 1 into 9. So when we add them, it comes to be 57 grams. Okay, so the empirical formula you have already formulated, and the mass of the empirical formula mass is 57. Okay, and as you can see, the molar mass is 114 gram per mole. Okay, as you can see over there. Okay, it's 114 gram per mole. Now last step. Now what you have to do, just divide the molar mass. Okay, so you have to find a number, okay, like n. So the molar mass, molecular formula mass, divide by empirical formula mass. So you are going to divide 114 divide by 57. Okay, so when you divide, you will get 2. Okay, and that number, what you will do, you will multiply that number with the empirical formula. So the molecular formula of this compound, unknown hydrocarbon, is going to be C8 is going to be C8 and H18. Okay, so this is the molecular formula of the organic compound. Okay, so then let me go over this example once again because it is a bit complicated. So when you are doing the molecular formula from the combustion analysis, actually what you have to do, you will take an organic compound and you will burn it in excess of oxygen. Okay, so when you burn it in excess of oxygen, there will be two products produced. You will get carbon dioxide and then you will be getting water. So in the question, they will give you the grams of carbon dioxide, as you can see from here, and then they will give you grams of water, right? So by using calculation, I told you already. So we can work out first from the carbon dioxide mass, we can work out the mass of carbon, right? And from water mass, the mass of water is given for you. You can see over here, 11.58 gram. From this mass, we can work out the grams of hydrogen, and the remaining calculations, you know it very well. Okay, so like we did before also, so you have to divide by the molar mass to get the moles and get the ratio. If the ratio is not a simple whole number ratio, you have to make it a whole number ratio. Okay, in this example, we have to multiply by 4, and when you multiply by 4, you get the whole number ratio, which is C4H9. Okay, and remaining step you know very well. Okay, so with this we will conclude our lesson. I hope you have understood everything. If there is any suggestion, you can send me comments in the comment box. Okay, and I hope to see you next time. Thank you.